Item 347. Thin overlay mixtures. 1. Description. Construct a thin surface course composed of a compacted mixture of aggregate and asphalt binder mixed hot in a mixing plant. Produce a thin overlay mixture, TOM, with a minimum lift thickness of ½ inch. For a Type F mixture and 3/4 inches. For a Type C mixture. 2. Materials. Furnish uncontaminated materials of uniform quality that meet the requirements of the plans and specifications. Notify the engineer of all material sources and before changing any material source or formulation. The engineer will verify that the specification requirements are met when the contractor makes a source or formulation change, and may require a new laboratory mixture design, trial batch, or both. The engineer may sample and test project materials at any time during the project to verify specification compliance in accordance with Item 6, Control of Materials. 2.1 Aggregate. Furnish aggregates from sources that conform to the requirements shown in Table 1 and as specified in this section. Aggregate requirements in this section, including those shown in Table 1, may be modified or eliminated when shown on the plans. Additional aggregate requirements may be specified when shown on the plans. Provide aggregate stockpiles that meet the definitions in this section for coarse, intermediate, or fine aggregate. Do not use reclaimed asphalt pavement, RAP, or recycled asphalt shingles, RAS. Supply aggregates that meet the definitions in Text 100E for crushed gravel or crushed stone. The engineer will designate the plant or the quarry as the sampling location. Provide samples from materials produced for the project. The engineer will establish the surface aggregate classification, SAC, and perform Los Angeles abrasion, magnesium sulfate soundness, and microdevol tests. Perform all other aggregate quality tests listed in Table 1. Document all test results on the mixture design report. The engineer may perform tests on independent or split samples to verify contractor test results. Stockpile aggregates for each source and type separately. Determine aggregate gradations for mixture design and production testing based on the washed sieve analysis given in Text 200F, Part 2. 2.1.1 Coarse aggregate. Coarse aggregate stockpiles must have no more than 20% material passing the number 8 sieve. Aggregates from sources listed in the department's Bituminous Rated Source Quality Catalog, BRSQC, are pre-approved for use. Use only the rated values for hot mix listed in the BRSQC. Rated values for surface treatment, ST, do not apply to coarse aggregate sources used in hot mix asphalt. For sources not listed on the department's BRSQC, build an individual stockpile for each material. Request the department test the stockpile for specification compliance, and, once approved, do not add material to the stockpile unless otherwise approved. Provide aggregate from non-listed sources only when tested by the engineer and approved before use. Allow 30 calendar days for the engineer to sample, test, and report results for non-listed sources. 2.1.1.1 Blending Class A and Class B aggregates. Class B aggregate meeting all other requirements in table may first be blended with a Class A aggregate to meet requirements for Class A materials. However, Class B aggregate may be disallowed when shown on the plans. Ensure that at least 50% by weight, or volume if required, of the material retained on the number 8 sieve comes from the Class A aggregate source when blending Class A and B aggregates to meet a Class A requirement. Blend by volume if the bulk specific gravities of the Class A and B aggregates differ by more than 0.300. The engineer may perform tests at any time during production, when the contractor blends Class A and B aggregates to meet a Class A requirement, to ensure that at least 50% by weight, or volume if required, of the material retained on the number 8 sieve comes from the Class A aggregate source. The engineer will use the department's mix design template, when electing to verify conformance, to calculate the percent of Class A aggregate retained on the number 8 sieve by inputting the bin percentages shown from readouts in the control room at the time of production and stockpile gradations measured at the time of production. The engineer may determine the gradations based on either washed or dry sieve analysis from samples obtained from individual aggregate cold feed bins or aggregate stockpiles. The engineer may perform spot checks using the gradations supplied by the contractor on the mixture design report as an input for the template. However, a failing spot check will require confirmation with the stockpile gradation determined by the engineer. 2.1.1.2 Microdevol abrasion. The engineer will perform a minimum of 1 microdevol abrasion test in accordance with TEX 461A for each coarse aggregate source used in the mixture design that has a rated source soundness magnesium, RSSM, loss value greater than 15 as listed in the BRSQC. The engineer will perform testing before the start of production and may perform additional testing at any time during production. The engineer may obtain the coarse aggregate samples from each coarse aggregate source or may require the contractor to obtain the samples. The engineer may waive all microdevol testing based on a satisfactory test history of the same aggregate source. The engineer will estimate the magnesium sulfate soundness loss for each coarse aggregate source, when tested, using the following formula. TxDOT equals RSSM times MDACT over RSMD, where TxDOT equals magnesium sulfate soundness loss, MDACT equals actual microdevol percent loss, RSMD equals rated source microdevol. When the estimated magnesium sulfate soundness loss is greater than the maximum magnesium sulfate soundness loss specified, the coarse aggregate source will not be allowed for use unless otherwise approved. The engineer will consult the geotechnical, soils, and aggregates branch of the construction division, and additional testing may be required before granting approval. 2.1.2 Intermediate aggregate. Aggregates not meeting the definition of coarse or fine aggregate will be defined as intermediate aggregate. Supply intermediate aggregates, when used, that are free from organic impurities. The engineer may test the intermediate aggregate in accordance with TEX 408A to verify the material is free from organic impurities. Supply intermediate aggregate from coarse aggregate sources, when used, that meet the requirements shown in Table 1 unless otherwise approved. Test the stockpile if 10% or more of the stockpile is retained on the number 4 sieve and verify that it meets the requirements in Table 1 for crushed face count, TEX 460A, and flat and elongated particles, TEX 280F. 2.1.3 Fine aggregate. Fine aggregates consist of manufactured sands and screenings. Natural sands are not allowed in any mixture. Fine aggregate stockpiles must meet the gradation requirements in Table 2. Supply fine aggregates that are free from organic impurities. The engineer may test the fine aggregate in accordance with TEX 408A to verify the material is free from organic impurities. Use fine aggregate from coarse aggregate sources that meet the requirements shown in Table 1 unless otherwise approved. Test the stockpile if 10% or more of the stockpile is retained on the number 4 sieve and verify that it meets the requirements shown in Table 1 for crushed face count, TEX 460A, and flat and elongated particles, TEX 280F. Table 1. Aggregate quality requirements. See table in specifications. 1. Surface aggregate classification of A is required unless otherwise shown on the plans. 2. Used to estimate the magnesium sulfate soundness loss in accordance with Section 347.2.1.1.2, microdevol abrasion. 3. Only applies to crushed gravel. 4. Aggregates, without mineral filler or additives, combined as used in the job mix formula, JMF. Table 2. Gradation requirements for fine aggregate. Sieve size and percent passing by weight or volume. Sieve size 3/8 with 100% passing. Sieve size number 8 with 70 to 100% passing. Sieve size number 200 with 0 to 30% passing. 2.2 Mineral filler. Mineral filler consists of finely divided mineral matter such as agricultural lime, crusher fines, hydrated lime, or fly ash. Mineral filler is allowed unless otherwise shown on the plans. Use no more than 2% hydrated lime unless otherwise shown on the plans. Test all mineral fillers except hydrated lime and fly ash in accordance with TEX 107E to ensure specification compliance. The plans may require or disallow specific mineral fillers. Provide mineral filler, when used, that is sufficiently dry, free-flowing, and free from clumps and foreign matter as determined by the engineer. Does not exceed 3% linear shrinkage when tested in accordance with TEX 107E, and meets the gradation requirements in Table 3. Table 3. Gradation requirements for mineral filler. Sieve size and percent passing by weight or volume. Sieve size number 8 with 100% passing. Sieve size number 200 with 55 to 100% passing. 2.3 Bagus fines. Fines collected by the bagus or other dust collecting equipment may be reintroduced into the mixing drum. 2.4 Asphalt binder. Furnish performance graded, PG, asphalt binder with a high temperature grade of PG 76 or 70 and a low temperature grade as shown on the plans, in accordance with section 300.2.10, performance graded binders. 2.5 TAC code. Furnish CSS1H, SS1H, or a PG binder with a minimum high temperature grade of PG 58 for TAC code binder in accordance with item 300, asphalts, oils, and emulsions. Specialized or preferred TAC code materials may be allowed or required when shown on the plans. Do not dilute emulsified asphalts at the terminal, in the field, or at any other location before use. The engineer will obtain at least one sample of the TAC code binder per project in accordance with TEX 500C, Part 3, and test it to verify compliance with item 300, asphalts, oils, and emulsions. The engineer will obtain the sample from the asphalt distributor immediately before use. 2.6 Additives. Use the type and rate of additives specified when shown on the plans. Additives that facilitate mixing, compaction, or improve the quality of the mixture are allowed when approved. Provide the engineer with documentation such as the bill of lading showing the quantity of additives used in the project unless otherwise directed. 2.6.1 Lime and liquid anti-stripping agent. When lime or a liquid anti-stripping agent is used, add in accordance with item 301, asphalt anti-stripping agents. Use no more than 1% hydrated lime when using crushed gravel. Do not add lime directly into the mixing drum of any plant where lime is removed through the exhaust stream unless the plant has a bagus or dust collection system that reintroduces the lime into the drum. 2.6.2 Warm mix asphalt, WMA. Warm mix asphalt, WMA, is defined as HMA that is produced within a target temperature discharge range of 215 degrees Fahrenheit and 275 degrees Fahrenheit using approved WMA additives or processes from the department's MPL. WMA is allowed for use on all projects and is required when shown on the plans. When WMA is required, the maximum placement or target discharge temperature for WMA will be set at a value below 275 degrees Fahrenheit. Department-approved WMA additives may be used to facilitate mixing and compaction of HMA produced at target discharge temperatures greater than 275 degrees Fahrenheit, however, such mixtures will not be defined as WMA. 2.7 Recycled materials. Recycled materials are not allowed for use. 3. Equipment. Provide required or necessary equipment in accordance with item 320, equipment for asphalt concrete pavement. 4. Construction. Produce, haul, place, and compact the specified paving mixture. In addition to tests required by the specification, contractors may perform other QC tests as deemed necessary. At any time during the project, the engineer may perform production and placement tests as deemed necessary in accordance with item 5, control of the work. Schedule and participate in a mandatory pre-paving meeting with the engineer on or before the first day of paving unless otherwise shown on the plans. 4.1 Certification. Personnel certified by the department-approved hot mix asphalt certification program must conduct all mixture designs, sampling, and testing in accordance with Table 4. Supply the engineer with a list of certified personnel and copies of their current certificates before beginning production and when personnel changes are made. Provide a mixture design developed and signed by a Level 2 certified specialist. Provide Level 1A certified specialists at the plant during production operations. Provide Level 1B certified specialists to conduct placement tests. Table 4. Test methods, test responsibility, and minimum certification levels. See table in specifications. 1 Level 1A, 1B, and 2 are certification levels provided by the Hot Mix Asphalt Center Certification Program. 2 voids in mineral aggregates. 3 refer to Section 347.4.9.2.3, Production Testing for Exceptions to Using an Ignition Oven. 4 Profiler and operator are required to be certified at the Texas A&M Transportation Institute facility when surface test type B is specified. 4.2 Reporting and responsibilities. Use department-provided templates to record and calculate all test data, including mixture design, production, and placement QC/QA, control charts, and thermal profiles. Obtain the current version of the templates at http://www.txdot.gov/inside-forms-consultants-forms-site-manager.html or from the engineer. The engineer and the contractor will provide any available test results to the other party when requested. The maximum allowable time for the contractor and engineer to exchange test data is as given in Table 5 unless otherwise approved. The engineer and the contractor will immediately report to the other party any test result that requires suspension of production or placement or that fails to meet the specification requirements. Record and electronically submit all test results and pertinent information on department-provided templates. Subsequent sublots placed after test results are available to the contractor, which require suspension of operations, may be considered unauthorized work. Unauthorized work will be accepted or rejected at the discretion of the engineer in accordance with Article 5.3, conformity with plans, specifications, and special provisions. Table 5. Reporting schedule. See table in specifications. 1. These tests are required on every sublot. 2. Optional test. To be reported as soon as results become available. 3. To be performed at the frequency specified on the plans. Use the procedures described in Text 233F to plot the results of all quality control, QC, and quality assurance, QA, testing. Update the control charts as soon as test results for each sublot become available. Make the control charts readily accessible at the field laboratory. The engineer may suspend production for failure to update control charts. 4.3 Quality Control Plan, QCP. Develop and follow the QCP in detail. Obtain approval for changes to the QCP made during the project. The engineer may suspend operations if the contractor fails to comply with the QCP. Submit a written QCP before the mandatory pre-paving meeting. Receive approval of the QCP before beginning production. Include the following items in the QCP. 4.3.1 Project Personnel. For project personnel, include a list of individuals responsible for QC with authority to take corrective action. Current contact information for each individual listed, and current copies of certification documents for individuals performing specified QC functions. 4.3.2 Material Delivery and Storage. For material delivery and storage, include the sequence of material processing, delivery, and minimum quantities to assure continuous plant operations. Aggregate stockpiling procedures to avoid contamination and segregation. Frequency, type, and timing of aggregate stockpile testing to assure conformance of material requirements before mixture production, and Procedure for monitoring the quality and variability of asphalt binder. 4.3.3 Production. For production, include loader operation procedures to avoid contamination in cold bins. Procedures for calibrating and controlling cold feeds. Procedures to eliminate debris or oversized material. Procedures for adding and verifying rates of each applicable mixture component, example aggregate, asphalt binder, lime, liquid anti-strip, WMA. Procedures for reporting job control test results, and procedures to avoid segregation and drain down in the silo. 4.3.4 Loading and transporting. For loading and transporting, include type and application method for release agents, and truck loading procedures to avoid segregation. 4.3.5 Placement and compaction. For placement and compaction, include proposed agenda for mandatory pre-paving meeting, including date and location. Proposed paving plan, example paving widths, joint offsets, and lift thicknesses. Type and application method for release agents in the paver and unrollers, shovels, lutes, and other utensils. Procedures for the transfer of mixture into the paver, while avoiding segregation and preventing material spillage. Process to balance production, delivery, paving, and compaction to achieve continuous placement operations and good ride quality. Paver operations, example operation of wings, height of mixture in auger chamber, to avoid physical and thermal segregation and other surface irregularities, and procedures to construct quality longitudinal and transverse joints. 4.4 Mixture design. 4.4.1 Design requirements. The contractor may design the mixture using a Texas gyratory compactor, TGC, or a super pave gyratory compactor, SGC, unless otherwise shown on the plans. Use the typical weight design example given in Text 204F, Part I, when using a TGC. Use the super pave mixture design procedure provided in Text 204F, Part 4, when using a SGC. Design the mixture to meet the requirements listed in Tables 1, 2, 3, 6, and 7. 4.4.1.1 Target laboratory molded density when the TGC is used. Design the mixture at a 97.5% target laboratory molded density or as noted in Table 7. 4.4.1.2 Design number of gyrations, and design, when the SGC is used. Design the mixture at 50 gyrations, and design. Use a target laboratory molded density of 96% to design the mixture, however, adjustments can be made to the end design value as noted in Table 7. The end design level may be reduced to no less than 35 gyrations at the contractor's discretion. Use an approved laboratory from the department's MPL to perform the Hamburg wheel test, and the department will perform the overlay test and provide results with the mixture design, or provide the laboratory mixture and request that the department perform the Hamburg wheel test and overlay test. The engineer will be allowed 10 working days to provide the contractor with Hamburg wheel test and overlay test results on the laboratory mixture design. The engineer will provide the mixture design when shown on the plans. The contractor may submit a new mixture design at any time during the project. The engineer will verify and approve all mixture designs, JMF1, before the contractor can begin production. Provide the engineer with a mixture design report using the department-provided template. Include the following items in the report: the combined aggregate gradation, source, specific gravity, and percent of each material used. The target laboratory molded density, or end design level when using the SGC. Results of all applicable tests. The mixing and molding temperatures. The signature of the Level 2 person or persons that performed the design. The date the mixture design was performed, and a unique identification number for the mixture design. Table 6. Master gradation limits, percent passing by weight or volume, and volumetric requirements. See table in specifications. 1. Defined as maximum sieve size. No tolerance allowed. 2. Unless otherwise shown on the plans or approved by the engineer. 3. Voids in mineral aggregates, VMA. Table 7. Laboratory mixture design properties. See table in specifications. 1. Unless otherwise shown on the plans or approved by the engineer. May 2nd be adjusted within the range of 35 to 100 gyrations when shown on the plans or specification or when mutually agreed between the engineer and contractor. 4.4.2 Job Mix Formula Approval. The Job Mix Formula, JMF, is the combined aggregate gradation, target laboratory molded density, or end design level, and target asphalt percentage used to establish target values for hot mix production. JMF1 is the original laboratory mixture design used to produce the trial batch. When WMA is used, JMF1 may be designed and submitted to the engineer without including the WMA additive. When WMA is used, document the additive or process used and recommended rate on the JMF1 submittal. The engineer and the contractor will verify JMF1 based on plant-produced mixture from the trial batch unless otherwise approved. The engineer may accept an existing mixture design previously used on a department project and may waive the trial batch to verify JMF1. The department may require the contractor to reimburse the department for verification tests if more than 2 trial batches per design are required. 4.4.2.1 Contractor's Responsibilities. 4.4.2.1.1 Providing gyratory compactor. Use a TGC calibrated in accordance with TEX 914K when electing or required to design the mixture in accordance with TEX 204F, Part I, for molding production samples. Furnish an SGC calibrated in accordance with TEX 241F when electing or required to design the mixture in accordance with TEX 204F, Part 4, for molding production samples. Locate the SGC if used at the engineer's field laboratory and make the SGC available to the engineer for use in molding production samples. 4.4.2.1.2 Gyratory compactor correlation factors. Use TEX 206F, Part 2, to perform a gyratory compactor correlation when the engineer uses a different gyratory compactor. Apply the correlation factor to all subsequent production test results. 4.4.2.1.3 Submitting JMF1. Furnish a mix design report, JMF1, with representative samples of all component materials and request approval to produce the trial batch. Provide approximately 25 pounds of the design mixture if opting to have the department perform the Hamburg wheel test on the laboratory mixture, and request that the department perform the test. Provide approximately 50 pounds of the design mixture to perform the overlay test. 4.4.2.1.4 Supplying aggregates. Provide approximately 40 pounds of each aggregate stockpile unless otherwise directed. 4.4.2.1.5 Supplying asphalt. Provide at least 1 gal of the asphalt material and sufficient quantities of any additives proposed for use. 4.4.2.1.6 Ignition oven correction factors. Determine the aggregate and asphalt correction factors from the ignition oven in accordance with TEX 236F. Provide the engineer with split samples of the mixtures before the trial batch production, including all additives, except water, and blank samples used to determine the correction factors for the ignition oven used for QA testing during production. Correction factors established from a previously approved mixture design may be used for the current mixture design if the mixture design and ignition oven are the same as previously used unless otherwise directed. 4.4.2.1.7 Boil test. Perform the test and retain the tested sample from TEX 530C until completion of the project or as directed. Use this sample for comparison purposes during production. The engineer may waive the requirement for the boil test. 4.4.2.1.8 Trial batch production. Provide a plant-produced trial batch upon receiving conditional approval of JMF1 and authorization to produce a trial batch, including the WMA additive or process, if applicable, for verification testing of JMF1 and development of JMF2. Produce a trial batch mixture that meets the requirements in Table 8. The engineer may accept test results from recent production of the same mixture instead of a new trial batch. Obtain and provide approximately 50 pounds of trial batch mixture in a sealed container, box, or bags labeled with the CSJ number, mixture type, and date for the overlay test. 4.4.2.1.9 Trial Batch Production Equipment. Use only equipment and materials proposed for use on the project to produce the trial batch. 4.4.2.1.10 Trial Batch Quantity. Produce enough quantity of the trial batch to ensure that the mixture meets the specification requirements. 4.4.2.1.11 Number of trial batches. Produce trial batches as necessary to obtain a mixture that meets the specification requirements. 4.4.2.1.12 Trial batch sampling. Obtain a representative sample of the trial batch and split it into 3 equal portions in accordance with Text 222F. Label these portions as contractor, engineer, and referee. Deliver samples to the appropriate laboratory as directed. 4.4.2.1.13 Trial batch testing. Test the trial batch to ensure the mixture produced using the proposed JMF1 meets the mixture requirements in Table 8. Ensure the trial batch mixture is also in compliance with the Hamburg wheel test, overlay test, and drain down requirements listed in Table 7. Use a department-approved laboratory to perform the Hamburg wheel test on the trial batch mixture or request that the department perform the Hamburg wheel test. Obtain and provide approximately 50 pounds of trial batch mixture in sealed containers, boxes, or bags labeled with the CSJ, mixture type, lot, and sublot number for the overlay test. The engineer will be allowed 10 working days to provide the contractor with Hamburg wheel test and overlay test results on the trial batch. Provide the engineer with a copy of the trial batch test results. 4.4.2.1.14 Development of JMF2. Evaluate the trial batch test results after the engineer grants full approval of JMF1 based on results from the trial batch, determine the optimum mixture proportions, and submit as JMF2. Adjust the asphalt binder content or gradation to achieve the specified target laboratory molded density. The asphalt binder content established for JMF2 is not required to be within any tolerance of the optimum asphalt binder content established for JMF1, however, mixture produced using JMF2 must meet the voids in mineral aggregates, VMA, requirements for production shown in Table 6. If the optimum asphalt binder content for JMF2 is more than 0.5% lower than the optimum asphalt binder content for JMF1, the engineer may perform or require the contractor to perform Text 226F on Lot 1 production to confirm the indirect tensile strength does not exceed 200 psi and the overlay test exceeds 300 cycles. 4.4.2.1.15 Mixture production. Use JMF2 to produce Lot 1 after receiving approval for JMF2 and a passing result from the department's or a department-approved laboratory's Hamburg wheel test and the department's overlay test on the trial batch. If desired, proceed to Lot 1 production, once JMF2 is approved, at the contractor's risk without receiving the results from either the department's Hamburg wheel test or overlay test on the trial batch. Notify the engineer if electing to proceed without Hamburg wheel test and overlay test results from the trial batch. Note that the engineer may require up to the entire sublot of any mixture failing the Hamburg wheel test or overlay test to be removed and replaced at the contractor's expense. 4.4.2.1.16 Development of JMF3. Evaluate the test results from Lot 1, determine the optimum mixture proportions, and submit as JMF3 for use in Lot 2. 4.4.2.1.17 JMF adjustments. If JMF adjustments are necessary to achieve the specified requirements, make the adjustments before beginning a new lot. The adjusted JMF must be provided to the engineer in writing before the start of a new lot. Be numbered in sequence to the previous JMF. Meet the master gradation limits shown in Table 6, and be within the operational tolerances of JMF2 listed in Table 8. 4.4.2.1.18 Requesting referee testing. Use referee testing, if needed, in accordance with Section 347.4.9.1, referee testing, to resolve testing differences with the engineer. Table 8. Operational tolerances. See table in specifications. One contractor may request referee testing only when values exceed these tolerances. 2. When within these tolerances, mixture production gradations may fall outside the master grading limits, however, the percent passing the number 200 will be considered out of tolerance when outside the master grading limits. 3. Only applies to mixture produced for Lot 1 and higher. 4. Binder content is not allowed to be outside the limits shown in Table 6. May be obtained from asphalt meter readouts. 5. Test and verify that Table 7 requirements are met. 4.4.2.2 Engineer's responsibilities. 4.4.2.2.1 Gyratory compactor. For mixtures designed in accordance with Text 204F, Part I, the engineer will use a department TGC, calibrated in accordance with Text 914K, to mold samples for trial batch and production testing. The engineer will make the department TGC and the department field laboratory available to the contractor for molding verification samples, if requested by the contractor. For mixtures designed in accordance with Text 204F, Part 4, the engineer will use a department SGC, calibrated in accordance with Text 241F, to mold samples for laboratory mixture design verification. For molding trial batch and production specimens, the engineer will use the contractor-provided SGC at the field laboratory or provide and use a department SGC at an alternate location. The engineer will make the contractor-provided SGC in the department field laboratory available to the contractor for molding verification samples. 4.4.2.2.2 Conditional approval of JMF1 and authorizing trial batch. The engineer will review and verify conformance of the following information within 2 working days of receipt. The contractor's mix design report, JMF1. The department provided overlay test results. The contractor provided Hamburg wheel test results. All required materials including aggregates, asphalt, and additives, and the mixture specifications. The engineer will grant the contractor conditional approval of JMF1 if the information provided on the paper copy of JMF1 indicates that the contractor's mixture design meets the specifications. When the contractor does not provide Hamburg wheel test and overlay test results with laboratory mixture design, 10 working days are allowed for conditional approval of JMF1. The engineer will base full approval of JMF1 on test results on mixture from the trial batch. Unless waived, the engineer will determine the microdeval abrasion loss in accordance with Section 347.2.1.1.2, microdeval abrasion. If the engineer's test results are pending after 2 working days, conditional approval of JMF1 will still be granted within 2 working days of receiving JMF1. When the engineer's test results become available, they will be used for specification compliance. After conditionally approving JMF1, including either contractor or department supplied Hamburg wheel test results, the contractor is authorized to produce a trial batch. 4.4.2.2.3 Hamburg wheel and overlay testing of JMF1. If the contractor requests the option to have the department perform the Hamburg wheel test on the laboratory mixture, the engineer will mold samples in accordance with Text 242F to verify compliance with the Hamburg wheel test requirement in Table 7. The engineer will perform the overlay test and mold samples in accordance with Text 248F to verify compliance with the overlay test requirements in Table 7. 4.4.2.2.4 Ignition oven correction factors. The engineer will use the split samples provided by the contractor to determine the aggregate and asphalt correction factors for the ignition oven used for QA testing during production in accordance with Text 236F. 4.4.2.2.5 Testing the trial batch. Within one full working day, the engineer will sample and test the trial batch to ensure that the mixture meets the requirements in Table 8. The engineer will mold samples in accordance with Text 242F if the contractor requests the option to have the department perform the Hamburg wheel test on the trial batch mixture to verify compliance with Hamburg wheel test requirements in Table 7. The engineer will mold samples for the overlay test in accordance with Text 248F to verify compliance with the overlay test requirement in Table 7. The engineer will have the option to perform the following tests on the trial batch. Text 226F, to verify that the indirect tensile strength meets the requirement shown in Table 8, and Text 530C, to retain and use for comparison purposes during production. 4.4.2.2.6 Full approval of JMF1. The engineer will grant full approval of JMF1 and authorize the contractor to proceed with developing JMF2 if the engineer's results for the trial batch meet the requirements in Table 7. The engineer will notify the contractor that an additional trial batch is required if the trial batch does not meet these requirements. 4.4.2.2.7 Approval of JMF2. The engineer will approve JMF2 within one working day if the gradation meets the master grading limits shown in Table 6 and is within the operational tolerances of JMF1 listed in Table 8. The asphalt binder content established for JMF2 is not required to be within any tolerance of the optimum asphalt binder content established for JMF1, however, mixture produced using JMF2 must meet the VMA requirements shown in Table 6. The engineer may perform or require the contractor to perform Text 226F on Lot 1 production to confirm the indirect tensile strength does not exceed 200 psi if the optimum asphalt binder content for JMF2 is more than 0.5% lower than the optimum asphalt binder content for JMF1. 4.4.2.2.8 Approval of Lot 1 production. The engineer will authorize the contractor to proceed with Lot 1 production, using JMF2, as soon as a passing result is achieved from the department's or a department-approved laboratory's Hamburg wheel test and from the department's overlay test. The contractor may proceed at its own risk with Lot 1 production without the results from the Hamburg wheel test and overlay test on the trial batch. If the department's or department-approved laboratory's sample from the trial batch fails the Hamburg wheel test or overlay test, the engineer will suspend production until further Hamburg wheel tests or overlay tests meet the specified values. The engineer may require up to the entire sublot of any mixture failing the Hamburg wheel test or overlay test to be removed and replaced at the contractor's expense. 4.4.2.2.9 Approval of JMF3 and subsequent JMF changes. JMF3 and subsequent JMF changes are approved if they meet the master grading limits shown in Table 6, mixture requirements shown in Table 7, and are within the operational tolerances of JMF2 shown in Table 8. 4.5 Production operations. Perform a new trial batch when the plant or plant location is changed. Take corrective action and receive approval to proceed after any production suspension for non-compliance to the specification. 4.5.1 Storage and heating of materials. Do not heat the asphalt binder above the temperatures specified in Item 300, asphalts, oils, and emulsions, or outside the manufacturer's recommended values. Provide the engineer with daily records of asphalt binder and hot mix asphalt discharge temperatures, in legible and discernible increments, in accordance with Item 320, Equipment for asphalt concrete pavement, unless otherwise directed. Do not store mixture for a period long enough to affect the quality of the mixture, nor in any case longer than 12 HR unless otherwise approved. 4.5.2 Mixing and discharge of materials. Notify the engineer of the target discharge temperature and produce the mixture within 25 degrees Fahrenheit of the target. Monitor the temperature of the material in the truck before shipping to ensure that it does not exceed 350 degrees Fahrenheit, or 275 degrees Fahrenheit for WMA, and is not lower than 215 degrees Fahrenheit. The department will not pay for or allow placement of any mixture produced above 350 degrees Fahrenheit. Produce WMA within the target discharge temperature range of 215 degrees Fahrenheit and 275 degrees Fahrenheit when WMA is required. Take corrective action any time the discharge temperature of the WMA exceeds the target discharge range. The engineer may suspend production operations if the contractor's corrective action is not successful at controlling the production temperature within the target discharge range. Note that when WMA is produced, it may be necessary to adjust burners to ensure complete combustion such that no burner fuel residue remains in the mixture. Control the mixing time and temperature so that substantially all moisture is removed from the mixture before discharging from the plant. Determine the moisture content, if requested, by oven drying in accordance with Text 212F, Part 2, and verify that the mixture contains no more than 0.2% of moisture by weight. Obtain the sample immediately after discharging the mixture into the truck, and perform the test promptly. 4.6 Hauling operations. Clean all truck beds before use to ensure that mixture is not contaminated. Use a release agent shown on the department's MPL to coat the inside bed of the truck when necessary. Use equipment for hauling as defined in Section 347.4.7.3.3, Hauling equipment. Use other hauling equipment only when allowed. 4.7 Placement operations. Collect haul tickets from each load of mixture delivered to the project and provide the department's copy to the engineer approximately every hour, or as directed. Use a handheld thermal camera or infrared thermometer, when a thermal imaging system is not used, to measure and record the internal temperature of the mixture as discharged from the truck or material transfer device, MTD, before or as the mix enters the paver and an approximate station number or GPS coordinates on each ticket. Calculate the daily yield and cumulative yield for the specified lift and provide to the engineer at the end of paving operations for each day unless otherwise directed. The engineer may suspend production if the contractor fails to produce and provide haul tickets and yield calculations by the end of paving operations for each day. Prepare the surface by removing raised pavement markers and objectionable materials such as moisture, dirt, sand, leaves, and other loose impediments from the surface before placing mixture. Remove vegetation from pavement edges. Place the mixture to meet the typical section requirements and produce a smooth, finished surface with a uniform appearance and texture. Place mixture so that longitudinal joints on the surface course coincide with lane lines, or as directed. Ensure that all finished surfaces will drain properly. Place the mixture at the rate or thickness shown on the plans. The engineer will use the guidelines in Table 9 to determine the compacted lift thickness. The thickness determined is based on the rate of 110 to 115 pounds/square yard for each inch of pavement unless otherwise shown on the plans. Table 9. Compacted lift thickness. See table in specifications. 1 Compacted target lift thickness will be specified on the plans. 4.7.1 Weather conditions. 4.7.1.1 When using a thermal imaging system, the contractor may pave any time the roadway is dry and the roadway surface temperature is at least 32 degrees Fahrenheit. However, the engineer may restrict the contractor from paving surface mixtures if the ambient temperature is likely to drop below 32 degrees Fahrenheit within 12 HR of paving. Provide output data from the thermal imaging system to demonstrate to the engineer that no recurring severe thermal segregation exists in accordance with Section 347.4.7.3.1.2, Thermal Imaging System. 4.7.1.2 When not using a thermal imaging system, place mixture when the roadway surface temperature is at or above 60 degrees Fahrenheit unless otherwise approved. Measure the roadway surface temperature with a handheld thermal camera or infrared thermometer. The engineer may allow mixture placement to begin before the roadway surface reaches the required temperature requirements if conditions are such that the roadway surface will reach the required temperature within 1 HR of beginning placement operations. Place mixtures only when weather conditions and moisture conditions of the roadway surface are suitable as determined by the engineer. The engineer may restrict the contractor from paving if the air temperature is 70 degrees Fahrenheit and falling. Produce mixture with a department-approved WMA additive or process to facilitate compaction when the roadway surface temperature is below 60 degrees Fahrenheit or when the air temperature is 60 degrees Fahrenheit and falling. Produce the mixture with the WMA additive or process at a target discharge temperature higher than 300 degrees Fahrenheit. 4.7.2 Tack coat. Clean the surface before placing the tack coat. The engineer will set the rate between 0.04 and 0.10 gal of residual asphalt per square yard of surface area. Apply a uniform tack coat at the specified rate unless otherwise directed. Apply a uniform tack coat to all contact surfaces of curbs, structures, and all joints. Allow adequate time for emulsion to break completely before placing any material. Prevent splattering of tack coat when placed adjacent to curb, gutter, and structures. Roll the tack coat with a pneumatic tire roller to remove streaks and other irregular patterns when directed. The engineer may suspend paving operations until there is adequate coverage. 4.7.3 Laydown operations. 4.7.3.1 Thermal profile. Use a handheld thermal camera or a thermal imaging system to obtain a continuous thermal profile in accordance with TxDOT 244F. 4.7.3.1.1 Thermal segregation. 4.7.3.1.1.1 Moderate. Any areas that have a temperature differential greater than 25 degrees Fahrenheit, but not exceeding 50 degrees Fahrenheit, are deemed as having moderate thermal segregation. 4.7.3.1.1.2 Severe. Any areas that have a temperature differential greater than 50 degrees Fahrenheit are deemed as having severe thermal segregation. 4.7.3.1.2 Thermal imaging system. Review the output results when a thermal imaging system is used, and provide the automated report described in TxDOT 244F to the engineer daily unless otherwise directed. Modify the paving process as necessary to eliminate any recurring, moderate or severe, thermal segregation identified by the thermal imaging system. The engineer may suspend paving operations if the contractor cannot successfully modify the paving process to eliminate recurring severe thermal segregation. Density profiles are not required and not applicable when using a thermal imaging system. Provide the engineer with electronic copies of all daily data files that can be used with the thermal imaging system software to generate temperature profile plots upon completion of the project or as requested by the engineer. 4.7.3.1.3 Thermal camera. Take immediate corrective action to eliminate recurring moderate thermal segregation when a handheld thermal camera is used. Evaluate areas with moderate thermal segregation by performing water flow testing in accordance to TxDOT 246F and verify the water flow is greater than 120 seconds. Provide the engineer with the thermal profile of every sublot within 1 working day of the completion of each lot. Report the results of each thermal profile in accordance with Section 347.4.2, Reporting and Responsibilities. The engineer will use a handheld thermal camera to obtain a thermal profile at least once per project. Suspend operations and take immediate corrective action to eliminate severe thermal segregation unless otherwise directed. Resume operations when the engineer determines that subsequent production will meet the requirements of this section. Evaluate areas with severe thermal segregation by performing water flow testing in accordance to TxDOT 246F and verify the water flow is greater than 120 seconds. Remove and replace the material in any areas that have both severe thermal segregation and a failing result for water flow test unless otherwise directed. 4.7.3.2 Windrow operations. Operate windrow pickup equipment so that when hot mix is placed in windrows, substantially all the mixture deposited on the roadbed is picked up and loaded into the paver. 4.7.3.3 Hauling equipment. Use belly dumps, live bottom, or end dump trucks to haul and transfer mixture. End dump trucks are only allowed when used in conjunction with an MTD with remixing capability unless otherwise allowed. 4.7.3.4 Screed heaters. Turn off screed heaters to prevent overheating of the mat if the paver stops for more than 5 minutes. The engineer may evaluate the suspect area in accordance with Section 347.4.9.3.1.1, Recovered Asphalt Dynamic Shear Rheometer, DSR, if the screed heater remains on for more than 5 minutes while the paver is stopped. 4.8 Compaction. Roll the freshly placed mixture with a steel-wheeled roller without excessive breakage of the aggregate to provide a smooth surface and uniform texture. Operate the roller in static mode for TOM-F mixtures only. Do not use pneumatic tire rollers. Use the control strip method given in Text 207F, Part 4, to establish the rolling pattern. Thoroughly moisten the roller drums with a soap and water solution to prevent adhesion. Use only water or an approved release agent on rollers, tamps, and other compaction equipment unless otherwise directed. Use tamps to thoroughly compact the edges of the pavement along curbs, headers, and similar structures and in locations that will not allow thorough compaction with rollers. The engineer may require rolling with a trench roller on widened areas, in trenches, and in other limited areas. Use Text 246F to measure water flow to verify the mixture is adequately compacted. Measure the water flow once per sublot at locations directed by the engineer. Take additional water flow measurements when both of the following conditions occur. The temperature of the mixture before compaction is below 275 degrees Fahrenheit, and WMA is not used. The water flow rate should be greater than 120 seconds. Adjust the mix design or construction methods, when directed, if the water flow rate is less than 120 seconds. Allow the compacted pavement to cool to 160 degrees Fahrenheit or lower before opening to traffic unless otherwise directed. Sprinkle the finished mat with water or lime water, when directed, to expedite opening the roadway to traffic. 4.9 Acceptance Plan. Sample and test the hot mix asphalt on a lot and sublot basis. Suspend production if production test results fail to meet the operational tolerance requirements in Table 8 for any material property for 4 consecutive sublots until test results or other information indicates to the satisfaction of the engineer that the next material produced or placed will meet specification requirements. 4.9.1 Referee Testing. The construction division is the referee laboratory. The contractor may request referee testing if the differences between contractor and engineer test results exceed the maximum allowable difference shown in Table 8 and the differences cannot be resolved. The contractor may also request referee testing if the engineer's test results require suspension of production and the contractor's test results are within specification limits. Make the request within 5 working days after receiving test results from the engineer. Referee tests will be performed only on the sublot in question and only for the particular tests in question. Allow 10 working days from the time the referee laboratory receives the samples for test results to be reported. The department may require the contractor to reimburse the department for referee tests if more than 3 referee tests per project are required and the engineer's test results are closer to the referee test results than the contractor's test results. The construction division will determine the laboratory molded density based on the molded specific gravity and the maximum theoretical specific gravity of the referee sample. 4.9.2 Production Acceptance. 4.9.2.1 Production Lot. A production lot consists of 4 equal sublots. The default quantity for Lot 1 is 500 tons, however, when requested by the contractor, the engineer may increase the quantity for Lot 1 to no more than 2,000 tons. The engineer will select subsequent lot sizes based on the anticipated daily production such that approximately 3 to 4 sublots are produced each day. The lot size will be between 500 tons and 2,000 tons. The engineer may change the lot size before the contractor begins any lot. 4.9.2.1.1 Incomplete production lots. If a lot is begun but cannot be completed, such as on the last day of production or in other circumstances deemed appropriate, the engineer may close the lot. Close all lots within 5 working days unless otherwise allowed. 4.9.2.2 Production Sampling. 4.9.2.2.1 Mixture Sampling. Obtain hot mix samples from trucks at the plant in accordance with Text 222F. The sampler will split each sample into 3 equal portions in accordance with Text 200F and label these portions as contractor, engineer, and referee. The engineer will perform or witness the sample splitting and take immediate possession of the samples labeled engineer and referee. The engineer will maintain the custody of the samples labeled engineer and referee until the department's testing is completed. 4.9.2.2.1.1 Random sample. At the beginning of the project, the engineer will select random numbers for all production sublots. Determine sample locations in accordance with Text 225F. Take one sample for each sublot at the randomly selected location. The engineer will perform or witness the sampling of production sublots. 4.9.2.2.1.2 Blind sample. For one sublot per lot, the engineer will obtain and test a blind sample instead of the random sample collected by the contractor. Test either the blind or the random sample, however, referee testing, if applicable, will be based on a comparison of results from the blind sample. The location of the engineer's blind sample will not be disclosed to the contractor. The engineer's blind sample may be randomly selected in accordance with Text 225F for any sublot or selected at the discretion of the engineer. The engineer will use the contractor's split sample for sublots not sampled by the engineer. 4.9.2.2.2 Asphalt binder sampling. Obtain a 1 qt sample of the asphalt binder for each lot of mixture produced. Obtain the sample at approximately the same time the mixture random sample is obtained. Sample from a port located immediately upstream from the mixing drum or pug mill in accordance with Text 500C, Part 2. Label the can with the corresponding lot and sublot numbers, and deliver the sample to the engineer. The engineer may also obtain independent samples. If obtaining an independent asphalt binder sample, the engineer will split a sample of the asphalt binder with the contractor. The engineer will test at least one asphalt binder sample per project to verify compliance with Item 300, asphalts, oils, and emulsions. 4.9.2.3 Production testing. The contractor and engineer must perform production tests in accordance with Table 10. The contractor has the option to verify the engineer's test results on split samples provided by the engineer. Determine compliance with operational tolerances listed in Table 8 for all sublots. Take immediate corrective action if the engineer's laboratory molded density on any sublot is less than 95% or greater than 98% when using the SGC or less than 96.5% or greater than 98.5%. To bring the mixture within these tolerances. The engineer may suspend operations if the contractor's corrective actions do not produce acceptable results. The engineer will allow production to resume when the proposed corrective action is likely to yield acceptable results. The engineer may allow alternate methods for determining the asphalt binder content and aggregate gradation if the aggregate mineralogy is such that Text 236F does not yield reliable results. Provide evidence that results from Text 236F are not reliable before requesting permission to use an alternate method unless otherwise directed. Use the applicable test procedure as directed if an alternate test method is allowed. Table 10. Production and placement testing frequency. See table in specifications. 1. Testing performed by the construction division or as directed by the engineer. Cantabro loss is for informational purposes only. 2. The engineer may reduce or waive the sampling and testing requirements based on a satisfactory test history. 4.9.2.4 Operational tolerances. Control the production process within the operational tolerances listed in Table 8. When production is suspended, the engineer will allow production to resume when test results or other information indicates the next mixture produced will be within the operational tolerances. 4.9.2.4.1 Gradation. Suspend operation and take corrective action if any aggregate is retained on the maximum sieve size shown in Table 6. A sublot is defined as out of tolerance if either the engineer's or the contractor's test results are out of operational tolerance. Suspend production when test results for gradation exceed the operational tolerances for 3 consecutive sublots on the same sieve or 4 consecutive sublots on any sieve unless otherwise directed. The consecutive sublots may be from more than one lot. 4.9.2.4.2 Asphalt binder content. A sublot is defined as out of operational tolerance if either the engineer's or the contractor's test results exceed the values listed in Table 8. Suspend production when 2 or more sublots within a lot are out of operational tolerance or below the minimum asphalt binder content specified in Table 6 unless otherwise directed. Suspend production and shipment of mixture if the engineer's or contractor's asphalt binder content deviates from the current JMF by more than 0.5% for any sublot. 4.9.2.4.3 Voids in mineral aggregates, VMA. The engineer will determine the VMA for every sublot. For sublots when the engineer does not determine asphalt binder content, the engineer will use the asphalt binder content results from QC testing performed by the contractor to determine VMA. Take immediate corrective action if the VMA value for any sublot is less than the minimum VMA requirement for production listed in Table 6. Suspend production and shipment of the mixture if the engineer's VMA results on 2 consecutive sublots are below the minimum VMA requirement for production listed in Table 6. Suspend production and shipment of the mixture if the engineer's VMA result is more than 0.5% below the minimum VMA requirement for production listed in Table 6. In addition to suspending production, the engineer may require removal and replacement or may allow the sublot to be left in place without payment. 4.9.2.4.4 Hamburg wheel and overlay test. The engineer may perform a Hamburg wheel or overlay test at any time during production, including when the boil test indicates a change in quality from the material submitted for JMF1. The engineer may obtain cores and perform the Hamburg wheel test on any area of the roadway where rutting is observed in addition to testing production samples. Suspend production until further Hamburg wheel or overlay tests meet the specified values when the production or core samples fail to meet the Hamburg wheel or overlay test criteria in Table 7. Core samples, if taken, will be obtained from the center of the finished mat or other areas excluding the vehicle wheel paths. The engineer may require up to the entire sublot of any mixture failing the Hamburg wheel or overlay test to be removed and replaced at the contractor's expense. If the department's Hamburg wheel or overlay test or department-approved laboratory's Hamburg wheel test results in a remove and replace condition, the contractor may request that the department confirm the results by retesting the failing material. The construction division will perform the Hamburg wheel and overlay tests and determine the final disposition of the material in question based on the department's test results. 4.9.2.5 Individual loads of hot mix. The engineer can reject individual truckloads of hot mix. When a load of hot mix is rejected for reasons other than temperature, contamination, or excessive uncoated particles, the contractor may request that the rejected load be tested. Make this request within 4 HR of rejection. The engineer will sample and test the mixture. If test results are within the operational tolerances shown in Table 8, payment will be made for the load. If test results are not within operational tolerances, no payment will be made for the load. 4.9.3 Placement acceptance. 4.9.3.1 Placement lot. A placement lot consists of 4 placement sublots. A placement sublot consists of the area placed during a production sublot. 4.9.3.1.1 Recovered asphalt dynamic shear rheometer, DSR. The engineer may take production samples or cores from suspect areas of the project to determine recovered asphalt properties. Asphalt binders with an aging ratio greater than 3.5 do not meet the requirements for recovered asphalt properties and may be deemed defective when tested and evaluated by the construction division. The aging ratio is the DSR value of the extracted binder divided by the DSR value of the original unaged binder. Obtain DSR values in accordance with TxDOT T315 at the specified high temperature performance grade of the asphalt. The engineer may require removal and replacement of the defective material at the contractor's expense. The asphalt binder will be recovered for testing from production samples or cores in accordance with Text 211F. 4.9.3.1.2 Irregularities. Identify and correct irregularities including segregation, rutting, raveling, flushing, fat spots, matte slippage, irregular color, irregular texture, roller marks, tears, gouges, streaks, uncoated aggregate particles, or broken aggregate particles. The engineer may also identify irregularities, and in such cases, the engineer will promptly notify the contractor. The engineer may require the contractor to remove and replace, at the contractor's expense, areas of the pavement that contain irregularities and areas where the mixture does not bond to the existing pavement if the engineer determines that the irregularity will adversely affect pavement performance. The engineer may require the contractor to immediately suspend operations if irregularities are detected or may allow the contractor to continue operations for no more than 1 day while the contractor is taking appropriate corrective action. 4.9.4 Exempt production. When the anticipated daily production is less than 100 tons, all QC and QA sampling and testing are waived. The engineer may deem the mixture as exempt production for the following conditions. Anticipated daily production is more than 100 tons but less than 250 tons. Total production for the project is less than 2,500 tons. When mutually agreed between the engineer and the contractor, or when shown on the plans. For exempt production, the contractor is relieved of all production and placement sampling and testing requirements. All other specification requirements apply, and the engineer will perform acceptance tests for production and placement listed in Table 10. For exempt production, produce, haul, place, and compact the mixture as directed by the engineer, and control mixture production to yield a laboratory molded density that is within plus or minus 1.0% of the target density as tested by the engineer. 4.9.5 Ride quality. Measure ride quality in accordance with item 585, ride quality for pavement surfaces, unless otherwise shown on the plans. 5. Measurement. TOM will be measured by the ton of composite mixture. The composite mixture is defined as the asphalt, aggregate, and additives. The weights of asphalt and aggregate will be calculated based on the measured weight of TOM and the target percentage of asphalt and aggregate. Measure the weight on scales in accordance with item 520, weighing and measuring equipment. 5.1 Asphalt. The asphalt weight in tons will be determined from the total weight of TOM. Measured asphalt percentage will be obtained using Text 236F or asphalt flow meter readings, as determined by the engineer. Provide the engineer with a daily summary of the asphalt mass flow meter readings when used for measuring asphalt percentage unless otherwise directed. 5.1.1 Target percentage. The JMF target asphalt percentage will be used to calculate the weight of asphalt binder unless the measured asphalt binder percentage is more than 0.3 percentage points below the JMF target asphalt percentage or less than the minimum percentage specified in Table 6. Volumetric meter readings will be adjusted to 140 degrees Fahrenheit and converted to weight. 5.1.2 Measured percentage. The average measured asphalt percentage from each sublot will be used for payment for that lot's production when the measured percentage for any sublot is more than 0.3 percentage points below the JMF target asphalt percentage or less than the minimum percentage specified in Table 6. 5.2 Aggregate. The aggregate weight in tons will be determined from the total weight of TOM less the weight of the asphalt. 6. Payment. The work performed and materials furnished in accordance with this item and measured as provided under Section 347.5, measurement, will be paid for at the unit bid price for TOM, asphalt, of the binder specified and for TOM, aggregate, of the grade and sack specified. These prices are full compensation for surface preparation, materials including tack coat, placement, equipment, labor, tools, and incidentals. Trial batches will not be paid for unless they are included in pavement work approved by the department. Payment adjustment for ride quality will be determined in accordance with Item 585, Ride quality for pavement surfaces.